I'd like to talk a little bit about energy. I'd also like to mention Mrs. Grote, give her a shout out for the slides that I'm going to use, just so you know where they came from. I want to recognize her. She did a nice job organizing these. Energy is broadly defined as the capacity to do work or produce heat. There are 7 kind of common types that people break energy into: mechanical energy, the energy of engines and motors and things; thermal, heat energy, you can feel that from a heat lamp or something; radiant, of course, is light, from the sun; sound, you can feel that in front of a speaker or something; electrical, of course, we use that to power a lot of motors and things in our homes; chemical energy is what we're going to focus on a lot in this particular class. Again, that chemical energy is generally stored in bonds. And then, of course, there's also nuclear energy, which you've all heard of course. Kinetic energy is, there are 2 broad categories that we break these things into: kinetic and potential. Kinetic energy is the energy of motion, and it is directly related to temperature. The hotter something is, the faster its particles are moving. So when we look at maybe 2 desks, if one's at a higher temperature than another, if we could look at the actual particles in the desk, you would find that the desk at the higher temperature, the particles in there are actually oscillating back and forth at a higher temperature than the ones at the colder temperature, the lower temperature. So there's a direct relationship between temperature and kinetic energy. And also, just in general, kinetic energy is any kind of movement. You see the fan blade there. If you throw a baseball, of course, it has kinetic energy. To have kinetic energy, whatever it is must be moving. If you have a semi, a huge truck, but it's not moving, it has no kinetic energy. Potential energy is the energy of position. So if I take a rock on the ground, it has not very much potential energy. If I walk it up to the top of the Eiffel Tower and hold it over the edge, of course now it has a lot of potential. And if I let it go, that'll be translated into kinetic energy as it falls, and then as it hits the ground, it can do some sort of work. So, but notice again, there's some potential there. The higher I raise it, the more potential there is. Another example you see on the screen is the bow and arrow. The bow, when it is not pulled back, has very little potential, but as you pull it back, it has much more potential to push things forward. Now, there's also things like electrical potential energy. A battery has the ability to do work. It has a lot of potential. And again, if we complete the circuit, the electrons will flow and they will then run a motor or something like that. Another example you see in the bottom right would be a roller coaster. Again, when the roller coaster is sitting in the station, very little potential energy, but as it rises and climbs to the top of the hill, it has a lot more potential energy. Baseball. At the bottom, if you were to throw a baseball straight up, at the bottom when it first leaves your hand, it has the maximum kinetic energy, not as much potential. As it rises up into the air, it starts to slow down. So you'll notice the kinetic energy starts to decrease, but the potential as it falls, of course, is much higher. And then as it falls back down to the earth, again, you'll notice the potential decreases as it gets lower, but of course its kinetic will also increase. So you're kind of going back and forth there between potential and kinetic. So energy is transferred between a system and its surroundings. It can go from, if you have an exothermic, which we'll talk more about a little bit later, but basically a reaction that releases energy, it will release energy to its surroundings, and vice versa. It can absorb energy from its surroundings as well. Common example of a transfer that you may be familiar with would be photosynthesis, which hopefully you studied in biology prior to this class. The light from the sun conveys a lot of energy. Plants will absorb that. They then take carbon dioxide and water, and they use the energy to synthesize carbohydrates. We can then get those carbohydrates through by eating them or burning them, and then there's a lot of stored energy in the bonds. That's chemical potential energy, and if we eat that plant, we can get the energy from those bonds as we digest it. The stored energy in there can then give us power to do the things we need to do. If you take an old tree or something like that and burn it for energy, heat energy, again, there's stored energy in the lumber, in the wood, and when you burn it, you are releasing that. So the sunlight is being converted into stored energy in those carbohydrates through photosynthesis. We can reverse that process, combustion if you're burning a log, or cellular respiration if you're an organism and you're eating and digesting it. You can then get that energy from there. So again, energy is being transferred back and forth. There are a lot of transformations. As I said, light to chemical, electrical to thermal, if I heat something up at home. Chemical energy, I eat food, I then digest that and get the energy from there, and then I can go do things. I can ride a bike, I can think, I can read, I can walk, or what have you. And the same thing with gasoline. There's chemical energy, a lot of stored chemical energy in gasoline, and we release that through combustion to power cars. Energy, and I mentioned this a moment ago, energy absorbing changes. If something is absorbing energy from its surroundings, it is an endothermic reaction. That would be things like the baked potato and the ice packs that you see in the bottom left of the screen. Those ice packs, if you've ever done that, that's typically ammonium nitrate and water, and as the ammonium nitrate dissolves, it is an endothermic process. It pulls in energy from its surroundings, and so therefore the surroundings get cold. And if you were to injure yourself, a trainer might get one of those, break the bag of water that's in there, and then apply that to the injured area to cool it down. Exothermic reactions obviously are those that release energy. Exo, it exits. Hand warmers, foot warmers, you've all probably used those in the winter, and a fire, of course, is an exothermic reaction.